Hello friends, grab your coffee, grab your cookie, and today keep both far away from any stone cutting table because we are talking about granite dust, marble dust, and quartz dust. These are some of the heaviest, most abrasive, and most dangerous mineral dust in industrial and construction environments. My name is Michael Klepik, and for 15 years I have been designing air filtration and dust collection systems for stone fabrication shops, countertop manufacturing, mining, quarries, and concrete cutting operations. Let me show you exactly why stone dust requires strict engineering and strict compliance. What stone dust really is? Technical description. When granite, marble, or quartz is cut, polished, drilled, shaped, ground, or crushed, extremely fine particulate becomes airborne. Technically, first, granite dust and quartz dust contain crystalline silica ranging from 20% to 90%. Second, marble dust consists primarily of calcium carbonate and calcite particles. Third, particle sizes range from 0.2 microns to 50 microns, depending on tool speed. Fourth, the respirable fraction between 0.2 microns and 5 microns is the most hazardous. Fifth, bulk density of stone dust ranges from 1,400 to 2,000 kilograms per cubic meter. Granite dust and quartz dust are extremely toxic to lungs. Marble dust is less toxic but equally abrasive. Where stone dust appears in industry. Stone dust is generated in, first, granite and quartz countertop fabrication shops. Second, marble cutting, polishing, and restoration facilities. Third, concrete drilling and saw cutting. Fourth, stone quarries and mining operations. Fifth, crushing and screening plants for aggregates. Sixth, monument and architecture stone carving. Seventh, masonry grinding, drilling, and resurfacing. Every mechanical process involving stone releases large volumes of airborne dust. Why granite, marble, and quartz dust are dangerous health hazards. First, quartz and granite dust contain crystalline silica, a known carcinogen. Second, fine silica particles cause silicosis, an irreversible lung disease. Third, inhalation increases risk of lung cancer and chronic obstructive pulmonary disease. Fourth, marble dust irritates lungs, eyes, and skin but is less toxic. Fifth, all stone dust particles penetrate deep into the respiratory system. Equipment hazards first. Stone dust is extremely abrasive and destroys duct elbows, fans, and filters. Second, quartz particles embed into filter media and increase pressure drop. Third, heavy dust loads overwhelm undersized dust collectors. Fourth, dust layers increase housekeeping requirements. Fifth, high-density particles erode motor bearings and moving parts. Stone dust is both biologically harmful and mechanically destructive. OSHA regulations for crystalline silica. 29 CFR 1910.1053. Granite and quartz dust fall under the OSHA silica rule, which includes first, a permissible exposure limit of 50 micrograms per cubic meter. Second, mandatory exposure monitoring. Third, engineering controls and local exhaust ventilation. Fourth, respiratory protection when controls are insufficient. Fifth, medical surveillance for exposed workers. Marble dust is regulated under nuisance dust limits but still requires mitigation. Behavior of stone dust in airflow. From an engineering perspective, first, granite and quartz dust are heavy but stay airborne when freshly generated. Second, the respirable silica fraction behaves like extremely fine smoke. Third, marble dust clumps and cakes inside ductwork under humidity. Fourth, sharp edges of silica particles cut into filter membranes. Fifth, high loading rates cause rapid filter wear and increased pressure drop. For stone dust, I designed duct velocities between 4,500 and 6,000 feet per minute to prevent settling. Filtration equipment that works best: FOEH and cartridge collectors, excellent for fine silica dust. First, membrane-coated cartridges trap sub-micron quartz particles. Second, high-strength media resist abrasion. Third, pulse cleaning handles high-density loads. Baghouse Blizzard best for large stone shops and continuous cutting lines. First, rugged filter bags tolerate extremely abrasive dust. Second, large chambers provide stable airflow. Third, dropout zones reduce filter impact. Additional considerations: ceramic-lined elbows, abrasion-resistant inlet modules, secondary HEPA polishing stage for respirable silica. NFPA and OSHA compliance. OSHA granite and quartz dust require compliance with, first, OSHA silica rule 29 CFR 1910.1053. Second, exposure assessments. Third, engineering controls. Fourth, housekeeping requirements. Fifth, respiratory protection, NFPA. If stone dust is mixed with organic contaminants, first, NFPA 652, dust hazard analysis. Second, explosion venting if required. Third, proper grounding and bonding. Fourth, safe material transfer procedures. Silica alone is not combustible. but mixtures can be. Dust collector system designed for stone. Stone dust is dense, abrasive, sharp, and produced in massive quantities. A dust collector must handle continuous heavy loading. I design, first, a differential pressure sensor to monitor filter wear, since silica destroys filter media faster than most dust types. Second, automated hopper discharge using rotary valves or screw conveyors to keep up with high daily dust volume. Third, collection into super sacks, also known as bulk bags, for safe and long interval disposal. Fourth, steep-walled hoppers and abrasion-resistant surfaces to prevent buildup. Fifth, ceramic-lined elbows, inlet cones, and duct sections to reduce erosion. Sixth, reinforced dust collector housing for high-velocity abrasion zones. Seventh, high-pressure pulse cleaning and optional HEPA final filtration to manage respirable crystalline silica. This is a complete engineered system, not just a hood or pickup point. Dust from granite, marble, and quartz may look natural, but it is one of the most dangerous industrial dusts. Granite dust and quartz dust contain respirable crystalline silica, a severe health hazard. Marble dust is less toxic but equally abrasive. With high-efficiency filtration, reinforced ductwork, automation, and OSHA silica compliance, we can keep stone processing facilities safe and productive. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, stone belongs in your countertops, not inside your breathing zone. See you in the next video.